Hello everyone! Let's start the third section of the class, about the third section of the basic theory of knowledge. First, we need to understand the principle of adhesive bonding. Like many polymer materials, actually have no stickiness. So why do self-adhesive labels or tapes have a sticky property? There are many reasons for this. The first is interface bonding. The adhesive and the surface to be bonded need to be infinitely close. When it reaches this, 1/10 or 1% nanometer, which is called the eye level. In a very microscopic case, there is a physical bond between them. For example, a steel plate that we can see with our naked eyes, or glass plate, which looks very smooth to our naked eyes, but in fact, under the microscope, and magnify it 100,000 times, its surface actually has a certain roughness. Then when the cross-linking agent comes into contact with it, the first is physical contact. Physical contact. There will be an intermolecular force, a molecular attraction. This is the first reason. The second reason is the molecular structure of gravity and the molecular structure of the adhesive. We know that the polymer of the adhesive is linear and randomly arranged. When its molecular weight is within a certain range, it has a certain weak adhesiveness. When there are active groups in the long chain, such as impact and gunshot, these acute groups and the adherent, they will produce a hydrogen bond effect. This is the second hydrogen bond. One is the intermolecular force. The second is the hydrogen bond. The hydrogen bond is also a kind of intermolecular forces. The hydrogen bond is a force between molecules. This is the second one. Since electrophiles can increase its connectivity, we need to add some specific tackifying resins. There are many types of tackifiers, mainly rosin-based, and petroleum rosin, and synthetic rosin. After adding the tackifier in the long chain structure of the polymer, it will be embedded in the polymer chain. It will play a role in the middle of the polymer chain, making the chain segments more flexible and increases its wettability. For example, on a long chain, there are few points of connection. If you add tackifying resin here, it's effective. The effective connection points will increase, so its viscosity will increase. This may be difficult for everyone to understand, but you just need to know about it. So how to evaluate the quality of a collagen agent? In fact, what we often pursue is a kind of the level of its viscosity. We usually think that the higher the viscosity, the better its performance. But it's not true. There are three forces in it. The first is adhesion. The second is the initial viscosity. The third is the retention of viscosity. Actually, it's called holding force. The adhesive force directly reflects between the adhesive and the adherent the magnitude of the force. When we test, we usually use this 180-degree reverse glass and peel it in reverse. Of course, some will do 90-degree glass. The two forces, there will be a slight difference, but usually the 180-degree is used more. In the initial viscosity, there are two testing methods. In the tape industry, we usually use this rolling ball. There are many steel balls of different sizes. The larger the steel ball is, if this ball falls freely from here, it will stick to the top, the viscosity of the label we are testing. If it stops, it means what number of ball it is. The larger the ball number, the higher the initial viscosity is. There are also some small ones. This method may have some errors, including when cleaning, it's not cleaned cleanly, or the steel ball is not flat, the most commonly used. We still use an annular initial viscosity on our tensile tester, which is the label. When it instantly touches the lever, the maximum force when it is instantaneously contacted is the initial viscosity. We use a ring punch on our tensile tester. This data is relatively accurate. As for the holding force, the holding force is a continuous and sustainable grinding performance. We usually stick a 25 by 25 square, and then hang a 1 kilogram weight below it, and see if it slips or falls. The longer it lasts, the stronger its reliability is. So what does the size of the adhesive force depend on? The size of the adhesive force in the testing process. We measure a combination of 3 forces. One is the interface, the force separating the glue and the adherent. The separation force. The second one, when we peel it off at 180 degrees, the surface material and glue will deform. This is the force of the substrate. The force of deformation. That is to say, if we use the same glue with the same thickness and stick to the same substrate, if the surface material is PE or PP, the force measured will be different. That is, for PP or PE, the force of deformation is different. And the third is the force of glue deformation. It's the deformation of the glue. That is, the usual thickness we apply is about 20 microns. If we increase the thickness of the glue's viscosity will also increase. But there is an upper limit. That is to say, the thickness of the glue also affects the stickiness. There is an upper limit. It's not that the thickness, it's not exponential growth. When the glue is deformed, it will also help increase the adhesion. When we test, we usually encounter some special peel-off situations. Normal peel-off is like what we just saw. When we tear it apart, there is no residue on the steel plate. This is a normal peel-off situation. There are also some cases when the peel-off is being bonded. The glue will remain on the object. This is called residual glue. The situation of residual glue means that the cohesion and the adhesive force of the interface, it loses a normal balance state. That is to say, when the cohesive force of the glue is not strong enough, a part of it will remain on the steel plate. It is actually an internal cohesion failure. This force is not the force of interface molecule separation. It is actually 2 forces. The force of interface separation and the force of glue deformation are superimposed together. The force measured at this time will be higher than the single interface separation. Peel-off will be higher than that of the single interface. Another situation is when we peel it off. The glue is completely left on the steel plate, or the adherent, but there is no glue on the surface. This situation cannot reflect the actual strength of the glue. This is called glue peeling. It means that the glue completely separated from the surface material. These different forms of damage are very interesting. Then we can design a special label. To design a special label, called anti-counterfeiting label. First, let's look at the first anti-counterfeiting label. When we tear it open, there is no residue on the steel plate, and the part that shows the words is designed by special means. This kind of anti-counterfeiting label is called non-rotation. It's called non-rotation label because it doesn't rotate. The glue is not transferred to the cut object, so it's called non-rotation. This is one case. And the second case is called semi-turn. As the name suggests, the glue is transferred to part of the back of the knife, and there is also glue residue on the label. So it is called semi-turn. As you can see, there are glue marks on the object. Of course, this pattern can be designed. Meanwhile, there is also glue residue on the label, so it is called semi-transfer. There is another one. There is also a full transfer. No transfer. That means when we peel it off, there is no glue on the surface material. It is completely transferred to the bow. This is called full transfer. There is another way to prevent counterfeiting, is to easily destroy the surface material to achieve the purpose of anti-counterfeiting. For example, this fragile paper. After we stick it on, if we want to tear it off, the surface material must be destroyed. To achieve the purpose of anti-counterfeiting, it means it has been torn. It has been torn. This is a fragile paper. These are the common anti-counterfeiting methods. We just talked about one type of adhesive, three kinds of, a balance of these three forces. It doesn't mean that the higher the adhesive force, the better, or the higher the initial viscosity, the better. The higher the holding force is, among the three, there needs to be a balance. So, taking the bonding force as an example, the adhesive force reflects the collective situation of the three. When the adhesive force is relatively high, its holding power will be slightly worse. This is because it often leaves residue. It combines the interfacial separation force and glue, and destructive force. It doesn't mean that the higher the adhesion, the better. So we also need to take into account the holding power. When the holding force increases slightly, they have a certain degree of, there is a contradiction between them. The better the holding power is, the viscosity of the sticky surface will decrease slightly. So, for initial viscosity and retention, there is also a reverse effect. The higher the holding force is, the glue is harder, and more curing agent is added, so the initial viscosity will decrease. After the glue becomes hard, it feels hard. When it touches bow instantly, the force is insufficient. It needs a certain wetting time. They are opposite. So, when considering the performance of a glue, we should consider them comprehensively. Then let's talk about water-based glue, oil glue, and hot glue. These three types of adhesives, their adhesion, initial viscosity, and holding force. Comparing them, what is the level? Let's look at oil glue. Yes. For oil glue, because its molecular designability is relatively strong, so its adhesive force, its adhesion can be designed to be very high or very low. It's all possible. It can be high or low. What about its initial adhesion? Is the same, because glue can usually be made into a two component, and curing agent is added. If I want it to have high initial adhesion, I'll add less curing agent. If I want to lower the initial viscosity, I'll add more curing agent. But it's not just the curing agent that affects it, but also the molecules of the glue itself. And design structure also matter. So the holding power. The holding power. It can achieve the best among the three. Because it will add curing agent. We can choose different curing agents, or different amounts of curing agent. Its holding force is the best among the three. Then water glue. The adhesive force of water glue is among the three. Its designability is relatively narrow, is relatively low. Then, for initial viscosity, is slightly medium. Compared with hot glue, the initial viscosity of water glue is slightly lower, but compared to oil glue, generally speaking, we don't usually make the initial viscosity of oil glue very high. Compared with oil glue, the initial viscosity of water glue is slightly higher. Its holding power is also medium. Compared with hot glue, its holding power is good. Compared to oil glue, is better, but slightly worse than oil glue. Hot glue has the best initial viscosity. Is the best. And the adhesive force can also be relatively high. But its holding power is relatively poor. So when we choose to use it, we need to consider the usage environment and temperature. It's adherent. We cannot choose a single aspect to choose our glue. There are also some special types of adhesives, such as removable glue. When I repeatedly stick and tear it off repeatedly, the glue will not remain on the object. So this design is usually designed with oil-based glue because the oil glue has curing agent or molecular structure design, which can make it slightly harder. The resin in the tackifying resin can be reduced and lower viscosity. This achieves the effect of being able to be pasted repeatedly. There is another type. UV curing. UV cured solvent-free glue is actually acrylic. Which is Afric type. Its type is the same as oil and water glue, but when it polymerizes, there is no solvent. It contains some monomers and oligomers and photoinitiators inside. A disadvantage of photoinitiators is that it is not easy to control during the polymerization process. The instantaneous energy of photoinitiator, which is hard to control. Temperature can easily cause runaway polymerization. Its advantage is that it does not contain solvents, which is slightly more environmentally friendly. However, after polymerization, there will be more residual odors. For some high-performance and high-viscosity ones, we also use this UV type. UV acrylic pressure-sensitive adhesives. If the customer has strict requirements on the area, have very strict requirements for the smell, then we don't recommend it. It will have some residual odor. The monomer of acrylic acid. The smell is quite pungent. It can also achieve high, medium, and the viscosity can be adjusted. It can be adjusted according to the formula. There is another type of hot melt glue. I call it a similar product. Hot melt glue is actually our hot melt coating methods. Rubber type pressure sensitive adhesive. There is also a solvent type, which we may not use very often, but everyone must know that. There is a solvent-based rubber pressure sensitive adhesive. It's like this. What does it mean? It means that our rubber, including resin, are dissolved in the solvent. Then we can add curing agent in it. Because in hot melt adhesives, we don't add hot melt glue. It's in the form of a block in the hot melt method. We don't add curing agent, because when the hot melt adhesive is at 180 to 200 degrees, the curing agent will react. When in the melting furnace, it will solidify into a block to apply. But the solvent-based rubber is also very strong. It has a strong designability. I can choose the strength of the rubber itself, high or low, and the amount of the middle value. It can also add curing agent. Its holding power will be much better than the ordinary hot melt hot glue for hot melt walking. And its adhesiveness and holding power can also be maintained relatively well. So this is a special model. We don't use it very often now, but it has higher performance, which ensures both stickiness and retention. Of course, there are also risks in this cost. During the melting process, it requires continuous heating and stirring, and the use of solvents. Using solvents also increases costs. Hot melt coating method, which is cheaper in terms of cost. So why do we talk about these three forces today? There is another reason. In fact, we will later involve the post-process of thin cutting processing, because you only focus on one aspect of the property, such as high viscosity. I don't care about its holding power. In the process of film cutting, it will easily cause glue overflow. When the film cutting time is long, or the edges are left for a long time, the edge of the roll will overflow, and it's inconvenient to put it on the machine. This is what we need to consider comprehensively. Oh, there is another one. There is also a special one called silicone. Silicone is siloxane. It's siliconized. This rubber, which is its. In fact, the main formula is similar to other rubbers. It contains silicone rubber, silicone resin, and curing agent. But its biggest feature is temperature resistance. Heat resistance. It can withstand temperatures up to 200 degrees. It can be used for a long time at 150 to 200 degrees. It is completely different from, or ordinary rubber type is completely different. Why is that? It's because of the silicon-oxygen bond or silicon-hydrogen bond. Their breaking temperatures are different. That is, during the process of continuous heating, its molecular bonds will not break, or yellowing. This is a very good high-temperature resistant. Sometimes we also use silicone rubber, such as some products on capacitors, or some needs on batteries, where high-temperature resistance is required. Only silicone rubber can be used. And then we talked about today. Various types of adhesives are basically finished. Later, we will focus on specific products, the matching of the surface and bottom glue, including printing, die cutting, and printing, and some common problems that we often encounter, such as printing problems. We will explain them in detail later.